Hi students, once again welcome back to computer class. So in our last class we started studying about conversion of numbers, and first we studied about converting a decimal number into a binary number, and we also saw an example how to convert a decimal number into a binary number. And today let us study conversion of a binary number into a decimal number. Okay. So for converting a binary number into a decimal number, you have to follow some steps. Step number 1 is each digit is multiplied by 2 raised to power of its position. Okay. Each digit inside the binary number should be multiplied with 2 raised to power of that particular position. And step number 2 is add all the products calculated in step 1. Step number 3, the total is equivalent to the value in the decimal number system. Once again, step number 1, each digit is multiplied by 2 raised to power of its position. Step number 2, add all the products calculated in step 1. And step number 3, the total is equivalent to the value in the decimal number system. Okay, so these are the steps of how to convert a binary number into a decimal number. And let us study in detail about this using an example. Okay. So we have seen the steps of how to convert a binary number into a decimal form. First step is each digit inside the binary number, they should be multiplied with 2 raised to power of that particular position. So let us see how we can do that. Each digit, let us start from the right side, that is the digit which is present at units position. Okay. 0 into 2. Each digit, they should be multiplied with 2 raised to power of that particular position. For the position unit, for the digit which is present at units position, the power is 0. Okay. So 0 into 2 raised to 0. Next, let us move on to the tens position. The digit is 1. 1 into 2 raised to, for the digit at tens position, the power is 1. Okay. Next, let us move on to the hundreds position. For the digit, that is 0 into 2 raised to, for the digit which is present at hundreds position, the power is 2. Okay. And then moving on to the thousands position. The digit which is present at thousands position is 1. So 1 into 2 raised to, and the power for thousands position is 3. Okay. And let us add all these cases. We have to add all these cases. Okay. And let us put a bracket. And we are converting this binary number into decimal number, and the subscript for a decimal number is 10. Okay, so we can draw one more bracket and we can write the subscript as 10. Since we are converting this binary number into decimal number, we are providing the subscript as 10. Okay, and let us calculate these cases. 1 into 2 raised to 3. 1 into 2 raised to 3 is 8. Okay, then 0 into 2 raised to 2 means it is 4. Plus 1 into 2 raised to 1. 1 into 2 raised to 1 means it is 2. Plus 0 into 2 raised to 0 is 1. Okay. So calculating this, 1 into 8 is 8. Plus 0 into 4 is 0. Plus 1 into 2, 2. Plus 0 into 1, 0. Okay. Answer is 10. Okay. So by converting this binary number, we will be getting the decimal number as 10 subscript 10. Okay. Converting this binary number into the decimal form, the decimal form is 10 subscript 10. Okay. This is how we convert a binary number into a decimal form. First step is each digit which is present at this binary number, they should be multiplied into 2 raised to the power of that particular position. Okay. And second step is we have to multiply all the cases and we have to add them. And finally we will be getting the result. Okay. Next, let us look at another example. I want to convert this binary number into its decimal form. Okay. So first step is I have to move on to the units position. Okay. units position digit is 1. 1 into 2 raised to 0. The digit at tens position is 0. 0 into 2 raised to 1. And the digit at hundreds position is 0. So 0 into 2 raised to 2. And the digit at thousands position is 1. 1 into 2 raised to 3. And we have to add all these cases. And we have to put a bracket. Since we are converting them into decimal form, I have to put the subscript as 10. Okay. I have to put the subscript as 10. Look at this. 1 into 2 raised to 3 is 1 into 8. Okay. Plus 0 into 4. Plus 0 into 2. Plus 1 into 1. Okay. That is 2 raised to 3 is 8. 2 raised to 2 is 4. 2 raised to 1 is 2. And 2 raised to 0 is 1. Okay. And adding these numbers 8 plus 0 plus 0 plus 1. Okay. The answer is 9. 9 subscript 10. Okay. By converting this binary number into its decimal form, the decimal form is 9 subscript 10. Okay. So this is how we are converting a binary number into a decimal form. The third type of number system is octal number system. In octal number system, they consist of totally 8 digits and they are from 0 to 7. Okay, since it consists of 8 digit, the base will be 8. Okay, in octal number system, they totally consist of 8 digits. They are from 0 to 7 and therefore the base of the octal number system will be 8. Okay, and this type of number system is also a positional value system. Like binary number system and like decimal number system, octal number system is also a positional value system. For example, the octal number 12,570 subscript 8. It has got the base 8. Okay. Since the base is 8, we will be writing the subscript as 8. And see how the octal number has been represented. I have marked over there. Okay. This is how we represent a octal number. 12,570 subscript 8. That is, we will be writing 8 as the subscript. And each position in the positional value system represent the power of the base. Similar like binary and decimal number system. Okay. Each position in the positional value system, they represent the power of base. And the steps for converting an octal number into a decimal number, they are similar to those we used in the conversion of a binary number into a decimal number. Okay. So, for converting an octal number into a decimal number system, we follow the same step like that of the conversion of a binary number into a decimal number. And the only difference here is that in the octal number system, each digit is multiplied with 8 raised to the power of its position. In converting a binary number into decimal number, we multiplied each digit with 2 raised to power of that particular position. And here in octal number system, for converting them into decimal number, each digit should be multiplied with 8 raised to power of that position. Why? Because octal number system, they has got the base 8. That is why we are multiplying each digit with 8 raised to power of that particular position. Okay. So we follow the same steps like how we converted a binary number into decimal number. Only difference is that each digit should be multiplied with 8 raised to power of that position. So once again, octal number system, they consist of totally 8 digits. They are from 0 to 7 and they has got the base 8. So for converting an octal number into its decimal equivalent, we have to multiply each digit by 8 raised to the power of that particular position. For converting a binary number into a decimal form, we have to multiply each digit into 2 raised to power of that particular position. So the difference is that in binary system we used 2 and in octal system we are using 8 because the base for an octal number is 8. Okay, that is why we are multiplying each digit with 8 raised to power of that particular position. Okay, so let us see how we can convert this octal number into its decimal form. So first taking the digit at units position, that is 7 into 8 raised to 0. Next digit is at tens position. Okay, so that is 3 into 8 raised to 1. Then for the digit at hundreds position, that is 2 into 8 raised to 2. Then for the digit at thousands position is 1 into 8 raised to 3. Okay, we have to add all these cases and we have to put bracket. Since we are converting them into decimal form, the subscript will be 10. Okay, and let us multiply these cases. 1 into 8 raised to 3 is 512. Okay, plus 2 into 8 raised to 2 is 64. 4 plus 3 into 8 raised to 1 is 8. Plus 7 into 8 raised to 0 is 1. Okay, this subscript 10. So 1 into 512 is 512. Plus 2 into 64 is 64 into 2. 8 times 12. 128. 128 plus 3 into 8 is 24. Plus 7 into 1 is 7. Okay, this subscript 10. 24 plus 7 is 31. Plus 512 plus 128 is 10 times 4, 6. 640 plus 31. Okay, 640 plus 31 is 176. 671 subscript 10. It is the decimal form by converting this octal number. Okay, so for converting an octal number into its decimal form, we have to multiply each digit with 8 raised to power of that particular position, and by converting this number, this octal number, into its decimal form, the decimal form that we got is 671 subscript 10. So the last number system is hexadecimal number system. Hexadecimal number system consists of 16 digits and some symbols. Since it consists of 16 digits, its base will be 16. Okay, hexadecimal number system totally consists of 16 digits and its base is said to be 16. Okay, and inside this number system they consist of 10 digits. They are from 0 to 9. Okay, and rest are 6 letters. They are from A to F. Okay, in this number system there are 10 digits. They are from 0 to 9 and rest of them are 6 letters which are from A to F. A means it is 10, B means 11, C means 12, D means 13, E means 14 and F means 15. Okay, totally inside hexadecimal number system there are 16 digits. So its base is 16. And inside this number system, first 10 digits they are from 0 to 9 and rest of them are letters from A to F. A means 10, B means 11, C means 12, D means 13 and E means 14, F means 15. That is, from A to F they are represented by the numbers 10 to 15. Okay, so totally in hexadecimal number system there are 16 digits and some symbols. So with this we come to the end of this chapter, that is number system. In this chapter we studied about decimal number system, binary number system, octal number system, and at last hexadecimal number system. Okay. Thank you.